Hey everyone, and welcome to this explainer. Today, we're decoding something pretty fascinating: how chemists use this brilliant, incredibly efficient shorthand to describe physical changes in the real world. Have you ever watched a piece of metal rust or a fire burn and wondered how a scientist actually writes that down in their notes without having to write out a massive paragraph? Well, we are going to break down exactly how that works today.
So think about it this way. Imagine you're texting a friend a really long, complicated message. You probably aren't typing out every single word, right? You use abbreviations, quick shorthand, or acronyms to get your point across as fast as possible. Well, guess what? Chemists have been doing the exact same thing for centuries. We're going to look at how chemical symbols act as the ultimate time-saving tool in the laboratory. It's literally an entire language designed purely to replace drawn-out sentences with specific symbols, built entirely for speed and precision. All right, let's jump right into Section 1, the chemist's secret shorthand.
Moving right along to Section 2, writing the word equation. Okay, so before we jump straight into the heavy chemistry symbols, we actually start by mapping out a really well-explained chemical equation in words. It's kind of like a rough draft that translates physical reality onto paper. A word equation is just a simple list. You've got your starting materials, the reactants, on the left, and your newly formed materials, the products, on the right. It perfectly anchors the before state of our chemical reaction on the left side of the page and the after state on the right side. It's basically a literal timeline of a physical change. Let's look at a really concrete example of this timeline. We have magnesium plus oxygen, pointing to magnesium oxide. Now, this right here is a perfect word equation. Everything is well explained in words. But you can probably already see the limitation here, can't you? It reads exactly like a clunky, long-form sentence. I mean, imagine having to write magnesium and oxygen out completely every single time you ran this experiment in the lab. It just takes up way too much time and space.
Which brings us to our next step, Section 3, the skeletal equation upgrade.
So here is that translation in action. On one side, we have our clunky word equation, magnesium plus oxygen giving us magnesium oxide. But check out the other side. We have our highly efficient skeletal equation, Mg plus O2 giving us MgO. We've taken those long English words and morphed them directly into their chemical formulas, which represent the exact substances involved. It's the exact same reaction, just written in a much faster, truly universal language.
Now let's break this down a bit more in Section 4, anatomy of the equation.
So now that we have our newly formed skeletal equation, we need to break down its specific anatomy so you know exactly how to read it piece by piece, just like a pro chemist does. Let's walk through the structure. Step 1, the reactants. These are your starting materials, and just like with the word equation, they always go on the left side. Step 2, the products. This is what you create, and they strictly belong on the right side. Step 3 is that really important arrow pointing to the right. That arrow is vital. It translates to gives or produces. And finally, Step 4, the plus sign. We use this to separate multiple substances, whether you have two different reactants mixing together on the left, or maybe two different products being formed on the right.
And this leads us to Section 5, the golden rule. Okay, so you know the anatomy now, but there is one trap that students fall into over and over again. The absolute most crucial point of this explainer comes down to this specific high-stakes warning straight from CBSE guidelines. Never, ever confuse the equal sign with the arrow. Now, I know it is incredibly tempting because a chemical equation looks a whole lot like a math equation, but in chemistry, substituting an equal sign is fundamentally and chemically incorrect. An equal sign means two things are currently the exact same. But an arrow means a transformation has actually occurred. It gives or produces something entirely new. If you use an equal sign on an exam, you will absolutely lose marks for sure. To wrap up our understanding of this shorthand, just remember this quick checklist. Always write your formulas correctly first. The skeletal equation has to be absolutely 100% accurate in its symbols before you even try to do anything else with it. Getting that written out perfectly is your essential first step to mastering chemical reactions. But hold on a second. Let's look closely at our skeletal equation again. Mg plus O2 giving us MgO. Is our equation actually balanced? I mean, look at it. We have two oxygen atoms on the left side of the arrow, but it looks like there's only one on the right. Have we somehow just lost an oxygen atom into thin air? Well, we are going to leave you with that puzzle for now. You are perfectly primed and ready to investigate how we balance these equations in your next learning session. Thanks so much for joining me on this explainer, and I'll see you next time.